Hello everyone, my name is Sajid Montazeri and here I am with another tutorial on Grasshopper. I hope you're doing great. Let's get started. At first, I type XYZ as always to utilize a construct point and place the point at the origin of the coordinate system. Next, I use a linear array to duplicate the point. To do this, I connect the point to the geometry input of the linear array component. Since the array requires a direction, I specify the x-axis as its direction. I then introduce the unit x factor and assign a factor value, for example, 0.5. Which makes the points more compact. Additionally, I define the count value to determine the number of points, setting, for example, 150 in this case, to have more numbers of points. Now I need to access the individual components of these generated points. For this, I use the construct component. I type the construct component. I connect the points to the geometry input, and it provides the x, y, and z coordinates separately for each point. Again, I want to use these three components to generate a new set of points, so I type x, y, z once more and bring in the construct component. If I directly connect the two x, nothing will be changed and the same point will be recreated. However, I want to introduce some variation. To do this, I use expression component. So I type it, I bring it, and I double click on it to open a formula editor. Here I can write a mathematical formula using the available input variable. Since I only need one input, I zoom in and remove the second input. Additionally, I don't want the input variable name to be too longer, so I right click on it and remove the default x variable. So now I define the formula x times sine of x. I apply this formula by connecting the, let's say, x input to the expression component and then fitting its output back into the x. Therefore, instead of directly using the original x values, they are first modified by multiplying them by their own sine value. I can make a copy of this component and this time using the cosine function instead of sine and assign this y input to it, creating a different variation like this. To better visualize the result, I can use an interpolate component. So I type interpolate, I bring it and connect the points together. Like this. And as you can see, it generates a spiral-like surface. For now, I don't need the interpolate component. It was just for previewing the shape. Now these construct points can be used as inputs for Voronoi components. I bring it, I connect the points to its input. As you can see, it generates the Voronoi cells like this. The Voronoi component also has radius input. For example, I can set the radius to 7, which results in smaller Voronoi cells. Since we are working parametrically, you can easily adjust different values and instantly see the updated result. For example, here I can increase the number of points. I can also modify the unit value in this section, and as you can see, it creates some really interesting shape. I'll set this value to, let's say, 0.34, and we can observe how the pattern evolves. I choose 74 numbers of points, but I think 90 should work better. In this section, I can also adjust the radius slightly to fine-tune the shape. You can play with it and slightly change. Now we can extrude all the generated Voronoi cells to give them height. I bring extruded component by typing it. I connect the cells to the basic input of the extruded component. For the extrusion direction, I used unit Z, so the shape extend vertically. As you can see, the cells are now elevated. You can also use a cap holes component. I connect the extrusion to the cap holes input. And in this next section, to make the result vertically clear, I use custom preview for better shading. And also for having a better color, you can use color swatch to apply a custom color to the geometry. Now you can clearly see the final result. We don't need previous components, so we hide them. Right now, the extrusion we get is uniform. If we want to make it more interesting, we can use a remap number component after the Voronoi cells. So I bring the remap number component. I take the values from cells and use bounds. So I type also bounds, define the input and output range. The cells are connected to the number input and the domain output is linked to the surface input of remap number. Instead of manually setting a target range, I can use a graph mapper. So I type graph mapper here and I bring it and connect it to the remap output. I right click, select graph type. So for example, here I choose sync. I extend the graph to the right to develop the pattern further. Now, instead of using a fixed Z unit factor, I connect the graph mapper output for the extrusion height. For extra variation, I use a multiplication component. So I type it. I set graph mapper output as input A. I connect it and also connect the result for the factor input. Since P is 1 by default, no visible change occurs yet. And I manually input a number here. For example, let's say I connect 11 with two decimal places to this input, and you can see the result looks like this. Now you can add another graph mapper to make the effect even more interesting. So I duplicate the existing graph mapper like this and connect its input here. I right click, set the graph type to sign and connect its input to, let's say, A. I adjusted it slightly to avoid getting zero values in this case. Now, if you experiment with different graph mapper setting, you'll see some really fascinating results. We can also tweak the sign function's domain to shift up or down as needed. And if the height is too high, you can control it from uh, this section. You can play with it and set it as you like. Finally, I switched display render mode to get a clearer view of the result. Here again, I can change its mode like this. For example, I select the graph mapper, right click, and this time set it for Perlin. And it is clear that Perlin also produces interesting results, and we can work with it to achieve different effects. This method is highly effective for modeling various landscapes. Once you're satisfied with the result, you can bake your work. How? Like this. You should right click, select bake, and save it to, let's say, layer 1. I click OK. Next, I select the entire algorithm, right click, and turn off the preview so that's no longer visible. Now you can select all the elements and move them around. You can also adjust the landscape, removing and any unnecessary elements. For instance, you can use these as platforms or consider the inner section as water features. You could also place trees on some platforms to create custom landscapes like this. I hope you enjoyed this tutorial and I'll see you in the next session. Thank you so much.